Okay, so we're going to look just now at question number 4 from the 2014 National 5 physics paper. It says a student fishing from a pier counts 4 waves passing the end of the pier in 20 seconds. So the key things we've got here so far are that there are 4 waves, they pass the pier in 20 seconds. The student estimates that the wavelength of the waves is 12 meters. So I'm just going to write down some things here. That's the wavelength. If there are 4 waves in 20 seconds, this is clearly a time, and this is the number of waves. It's not drawn to scale. Calculate the speed of the water waves. Now there are 3 methods indicated in the marking scheme for doing this problem. Neither 1, 2, or 3 of them are right or wrong, or better or worse. They're all equally valid methods of doing the problem. There's probably a way that I would pick to do it, which I'll show first, and then we'll just talk through the other ways after that. So the way I would do it is I would read this question and say, well, if there's 4 waves in 20 seconds, I'd like to know what is the frequency of the wave. And the frequency of the wave, of course, is the number of waves in 1 second. And that is given as f is equal to n over t. So we've got 4 waves in 20 seconds, so we can easily calculate that if there's 4 waves in 20 seconds, oops, not 20, but 4, then the frequency is 0.2 hertz, and that's the number of waves in 1 second. Now we also have the wavelength. The wavelength is the distance from one wave to the next, maybe from the crest of one wave to the crest of the next, and that's equal to 12 meters. And so if you have these 2 pieces of information, the frequency and the wavelength, then you can calculate the speed. Speed is frequency times wavelength, which is equal to 0.2 times 12. And 0.2 times 12 is 2.4 meters per second. And that's the answer done. So that's one method of solving this problem, but of course there are others. So I'll go just through now the other ways of doing the problem. Let me clear the screen and we'll do it again. So an alternative method then is to think about the fact that if there are 12 waves, and if there are 4 waves, I should say, and each wave is 12 meters, then the total distance travelled by those 4 waves is 4 times 12. And 4 times 12 is 48 meters. So effectively those 4 waves will have travelled a distance of 48 meters. And the time that they've travelled that distance in is 20 seconds. And so we can easily do speed is equal to distance, 48, divided by time, which is 20. And 48 divided by 20 is 2.4 meters per second. So that's the second method of doing the problem. So we'll clear our screen again and we'll think about the final one. So in this method we're going to think about the period of the wave. Now the period is quite different to the frequency which we used in the first method. The frequency is the number of waves in 1 second, but the period is the time for one complete wave. Now the time for one wave, so the period is the time for one wave. And if 4 waves pass the end of the pier in 20 seconds, then the time for one wave is 20 divided by 4, which is 5 seconds. So that's the period of one wave. And we also know that one wave has a length, or travels a length of 12 meters. So therefore we can also use the formula speed equals distance over time like we did previously, but this time the length is 12 meters and the time is 5 seconds. And so that gives us our answer, which again is 2.4 meters per second. So I've explained the 3 methods for working out the speed of the wave, my preferred method is to use v equals f lambda, because the question seems to allude to it. 4 waves in 20 seconds, therefore the frequency is the number of waves in 1 second. Find that out. You've got the frequency, you've got the wavelength, and put the numbers into the equation v equals f lambda. But as I've said, whatever way you want to do it is fine, as long as you understand and explain what you've done.